In these examples, we're going to again take a look at our sum and difference formulas for sine and cosine. Even though these problems look very different, they're going to just be as simple as recognizing that we have two angles. In this case, I'm trying to find the cosine of the difference of those two angles. So to begin this problem, I'm actually going to start with something we've done before and actually change A and B into two triangles. So let me go ahead and make two quadrants, one for angle A and one for angle B. Okay? And so let's start with angle A. I want to figure out first which quadrant to draw this angle in. Well, just like we did previously in some other examples, we know that inverse sine is going to be between one of these two quadrants. And to determine which quadrant to use, we have to take a look at whether our ratio is positive or negative. In this case, because that ratio is positive, that tells me to draw the angle in quadrant 1. If my ratio was negative, I would draw it in quadrant 4. For inverse sine. And really, I know two sides of this triangle because remember the sine ratio is equal to the opposite side over the hypotenuse. So I'm going to go ahead and label those two sides of my triangle. The opposite side is going to be 5 and the hypotenuse is going to be 13. Well, just like we've done before, we'll then do Pythagorean Theorem to find that third side. And you may recognize in this case that you do have a Pythagorean triple. That missing side is going to be 12. If you don't recognize that, or if it's not a Pythagorean triple, just go ahead and do your normal Pythagorean Theorem to find that missing side. And keep in mind, you may have to add a negative to that side. If your side is going to the left, you'd have to make that negative. If your side was going down, you'd have to make that negative as well. So in this case, it's just a positive 12. Okay? So that triangle's done. I'm going to go ahead and label that angle A, just so I'm being consistent with that A and B thing. Okay, so I'm going to leave that for right now, and let's go ahead and draw triangle B the same way. So for triangle B, this time it's working with an inverse tangent. And again, just like sine, inverse tangent is going to be between one of those two quadrants. Well, because my inverse tangent is positive, again, I'm going to stick with quadrant 1. If it was negative, I'd do it in quadrant 4. Okay? And just like before, I'm really given two sides of this triangle. Tangent stands for the opposite side over the adjacent side. So I know the opposite side is 3. And the adjacent side is 4, and again, doing Pythagorean Theorem or recognizing the fact I have a Pythagorean triple, I know that third side is going to be 5. Okay, so that's the first part of these problems, getting those two triangles drawn. The next step is I want to figure out, well, if you take a look at what's going to eventually have to happen, I need to figure out what cosine of A is, cosine of B, and so on. So I think at this point, let's go ahead and find those ratios for our two triangles. So for example, I'm going to need to know what the sine of A is, as well as what the cosine of A is. And doing that, once your triangle is drawn, shouldn't be too hard at all. The sine of A is the opposite side over the hypotenuse, and the cosine is the adjacent side over the hypotenuse. So there's two of the fractions we're going to need in our final answer. We'll do the same thing on triangle B. There's a lot of pre-work to do on these problems, a lot of steps that have to happen first. So I need to know the sine of angle B as well as the cosine of angle B. And again, we'll just call angle B that angle right there. So my sine is opposite over hypotenuse, so 3/5, and my cosine is the adjacent over the hypotenuse, so 4/5. Okay. Having these numbers, having all this work done, we're now ready to finally answer this question, which was to find the cosine of the difference of A minus B. So using the formulas from the previous day, I've gone ahead and broken that apart into this. And again, if you don't have that memorized, just take a look at your formula sheet, and from here, let's plug in these four values into that formula. So cosine of A was 12 over 13, and just be very patient at this part. It's very easy to make mistakes. Cosine of B is 4/5. The sine of A is 5 over 13, 5/13, and the sine of B is 3/5. Okay, and so at this point, it's simply a matter of doing some multiplication and adding some fractions together. So I end up with 48 when I multiply across the numerators over 65, and the second fraction when I multiply ends up as 15 over 65. And now notice I have the same denominator. That's going to be the case always. So now let's go ahead and just combine this into a single fraction. So adding my numerators, I get 63, and then my denominator stays the same. So my final answer is that, 63 over 65. So lots of pre-work to do to begin this problem, but once that's done, it's pretty quick to finish it. Okay, let's take a look at one more example. If you have the idea, it's going to be the same thing. But let's look at one more example. This time, our numbers are not going to be as nice. So let's go ahead. Actually, you know what I want you to do? Can you go ahead and try the first couple steps? Can you get the triangles drawn and then find the sine and cosine of your different angles? So pause the video and try that. If you want to see my work pop up, just wait a couple seconds and I'll do it. But please pause the video, try those triangles, and then we'll finish this problem together. So there are my two triangles, and you'll notice they're both in quadrant 1. Once again, this time, both of my ratios were again positive, which told me to draw these in quadrant 1. Also, I had to do Pythagorean Theorem right here to find square root of 3. Hopefully you found that same thing. And then I found my 4 different ratios along the bottom. This time, the second triangle was a Pythagorean triple, so I knew that was 4, or you could have done Pythagorean Theorem. At this point then, my problem was to find the sine of the sum of two angles. It was sine, there was a sum in there, so really it's just the sine of a plus b. So using formulas from yesterday, I've gone ahead and broken that up into its individual pieces. And from here, let's just go ahead and plug in the different values we found below. So for example, we knew the sine of a was the square root of 3 over 2. The cosine of b was 4/5. The cosine of angle A was 1/2. And the sine of angle B was 3/5. So again, let's go ahead and just do some multiplication to combine that answer into a single fraction. So I end up with 4 times the square root of 3 over 10 as the first fraction, plus 3 over 10 as the second fraction. And because I have the same denominator, and you always will, I can add the numerators, although nothing actually adds this time. It's like different, they're not like terms, so unlike terms. So all I can say is 4 square root of 3 plus 3 over 10, and there is my exact value of the answer to this question. So not nearly as pretty of an answer as last time, but same procedure, same steps.